DeepMind was a research organization founded in 2010 that worked on artificial neural networks, or ANNs, for Atari 2600 games. DeepMind was acquired by Alphabet in 2014 after successfully developing said ANNs. As a subsidiary of Google, DeepMind has created 3 notable AIs under a CNN/machine learning framework. For simplicity's sake, I'll refer to these as ANNs. These are AlphaGo, AlphaZero, and AlphaFold. AlphaGo is a program trained to play Go. AlphaZero is a generalized version of AlphaGo designed to play chess, shogi, and Go. AlphaFold is an entirely separate ANN focused on predicting protein folding, and notably, DeepMind's only work outside of reinforcement learning. DeepMind also made AlphaStar, another ANN designed to play StarCraft 2. To put my criticisms of DeepMind into context, I should note the following. I believe that their work in machine learning, particularly reinforcement learning, has been very important and impactful. Between the earlier ANNs in Atari games and later AlphaZero, DeepMind has been instrumental in showing that ANNs perform well in reinforcement learning, particularly in regards to video games. DeepMind also illustrates how ANNs can be created and trained rapidly. My primary complaints of DeepMind come from the attempts by DeepMind to rig competitions in order to win rather than to show an actual comparison between their ANNs and their opponents. This act is particularly detrimental to the understanding and usage of ANNs, as a spectator could easily assume ANNs have a higher maximum ELO or performance ability than their traditional counterparts. The reality is more complicated, but in the long run, handcrafted functions and algorithms actually greatly outperform ANNs, as can most clearly be seen between Stockfish and AlphaZero. To put AlphaZero in context, I must first explain AlphaGo, the predecessor of AlphaZero. AlphaGo was an ANN designed to play Go, and first debuted in 2015. Over the course of the next 2 years, AlphaGo would break many records in Go, beating the highest ranked human player at the time, and going 60-0 online against many of the best professional players in the world. While met with great fanfare in Western media, the reality of a computer program being the first to reach this level of success was far less impressive. The reality was that there was no computer Go community, and no interest in the development of Go engines. Up to that point, the most accomplished Go program had been Zenith Go, which was developed by a single individual using an alpha-beta search algorithm. What AlphaGo did do was highlight the strengths of ANNs, particularly in that of not requiring in-depth knowledge of the game, in this case Go. On December 5th, 2017, DeepMind published, quote, Mastering Chess and Shogi by Self-Play with a General Reinforcement Learning Algorithm, end quote, in which they described how they had created an ANN and then trained it to play chess, shogi, and Go to superhuman levels. The paper further claimed to have beat both Stockfish and Elmo, the leading programs in chess and Go respectively. However, looking into the paper, there are many strange and glaring issues. I will focus on Stockfish and the chess side of the topic, as there was more public reaction and information available. But many of the same complaints were also raised in regards between games between AlphaZero and Elmo. The most notable was the engine version, time control, and hardware that each competitor used. The engine version was the most obvious. In the paper they used Stockfish 8, which at the time of publication was over a year old. Each engine was, quote, given 1 minute of thinking time per move. This was a completely nonsensical time control that does not exist in any chess setting, and Stockfish, nor any other engine, would have had any optimization to produce the best answer in the given time. On the hardware front, Stockfish was given 64 threads but only a hash size of 1 GB, AlphaZero used a machine which used 4 tensor processing units and other undisclosed hardware. Some contributors to Stockfish noted that Stockfish was not optimized for such high thread counts in relation to the limited hash size. The 1 GB hash size was severely undersized and limited communications between threads, creating an artificial handicap. These points were all made by the chess community and raised serious questions about the legitimacy of the results between AlphaZero and Stockfish. To further exacerbate the issue, DeepMind had not communicated nor consulted the Stockfish organization at all. DeepMind, it would seem, had created AlphaZero as a publicity stunt and attempted to use the computer chess community as the fall man. After the backlash created by the first paper, DeepMind published a second paper, quote, a general reinforcement learning algorithm that masters chess, shogi, and Go through self-play, end quote, in the Science Journal. DeepMind once again claimed to have decisively beat both Stockfish and Elmo. They also addressed 2 of the concerns that the chess community had on the earlier matches. Once again, I focus only on the chess side for the same reasons aforementioned and for continuity's sake. DeepMind addressed a timing control issue, this time choosing a format of 3 hours per game with a 15-second increment per move, and the small hash size of 1 GB was increased to 32 GB. However, there were 2 issues that remained unaddressed. The first was engine size. DeepMind still used Stockfish 8, which by now was 2 years old and had been outclassed by many other engines. The second issue was the hardware. Both AlphaZero and Stockfish were given 44 CPU cores, with AlphaZero receiving an additional 4 first-generation TPUs. The 44 CPU cores were from the Top Chess Engine Championship, or TSEC, format, and consisted of 2 Intel Xeon E5 2699 V4 CPUs. For functional comparison, Google claimed that, quote, on our production AI workloads that utilize neural network inference, the TPU is 15 to 30 times faster than contemporary GPUs and CPUs. Taking the lower end at 15 times and multiplying that by the 4 TPUs given to AlphaZero, the total processing of AlphaZero actually amounted to 61 CPUs. DeepMind functionally had created a hardware discrepancy, giving AlphaZero 31 times the processing power of Stockfish, and thus ensuring themselves a victory. However, when this hardware discrepancy is equalized by giving AlphaZero 30 times less time, Stockfish came out ahead, suggesting that given equivalent hardware, Stockfish would outperform AlphaZero. This is further backed up by Stockfish outperforming Leela Chess, which was an open source community project built off of AlphaZero pseudocode given in the papers. When Leela plays in tournaments, it usually places second or third, with Stockfish consistently placing first. In terms of rating, the CCRL places Leela at 25th and Stockfish at 1st, under the 40-15 time control. Stockfish's outperformance of Leela and AlphaZero showed once again that while ANNs have certain advantages, particularly in the development cycle, a dedicated program like Stockfish still outperforms it. As for AlphaStar, the ANN designed to play StarCraft 2, the story is fairly short. After AlphaZero, DeepMind worked with Blizzard to create a program capable of playing StarCraft 2. Blizzard would create an API that allowed for computer play, and DeepMind built the ANN. In early 2019, AlphaZero played against TLO and Mana, 2 professional SE2 players, beating them each 5-0. After these matches, it became clear that AlphaStar was winning due to its micro rather than macro. For the final live match against Mana, AlphaStar was changed to reduce its micro abilities drastically, though still above that of a human, and then given several weeks to be retrained. However, without the extreme edge on micro, the difference in macro became evident, as Mana found and exploited deficiencies in AlphaStar's decision making. DeepMind soon after abandoned the project, moving on to AlphaFold. As my understanding of biochemistry is extremely limited, My understanding and opinion of AlphaFold will be more general and brief. AlphaFold performs very well in predicting protein folding within its dataset. However, its ability to predict new protein chains is extremely poor. This is likely due to the complex and unpredictable nature of combining atoms into new molecules. DeepMind, through their many AIs, proved that ANNs were a viable method to approach games. The vast majority of video games and board games do not have programs capable of playing at or above human level, if at all. Often a lack of incentive, resources, or community are to blame. The list of reasons is innumerable. Game developers and players can leverage ANNs to create more natural and difficult opponents for games. ANNs are a cutting-edge technology, offering many advantages and disadvantages over traditional solutions. My gripe with DeepMind is the misrepresentation, both internal and external, of ANNs as some sort of technological holy grail capable of solving all problems at a higher level than any other solution. An ANN is a tool in a toolbox. There is a time and a place for them.